Three, two, one.
That takes a few seconds. Yep, you are live.
Okay, all right. Everyone, hello. Welcome to 96 Boards. My right side? Oh, dang it. 96 Boards Open Hours. This is episode 90. My name is Robert Wolff. We're coming to you live on February 8th. I guess that's the date today. February 8th. We have an exciting episode planned for you. We have a couple guests, one of which is going to speak about the 96 Boards Enterprise Cello board, the long lost cello board. So we have some really cool things to talk to you about there. And then we'll just kind of take questions. And just to remind everyone, right, because I do say this quite often, this is a very informal, very kind of hopefully fun call, right? That's why we do this on Blue Jeans. We do this on Blue Jeans instead of some, YouTube chat or hangout, because we want to interact, right? We encourage interaction. So please speak up, interrupt us whenever you feel like, right? Now, traditionally, I do a couple announcements. Then we'll go into introducing our guests and going into the segments, okay? So first things first, as we approach March, we will be coming up on our on our Lenaro Connect. And we do two of these big conferences every year. This one in March comes to you from Hong Kong. All right, so all the people from Lenaro, all the people from 96 Boards, we're gonna go over to Hong Kong. We're gonna be there for about a week. We're going to talk about all sorts of new things happening in Linux on ARM, right? So, and as well as many other open source initiatives. If you want to know more about Lenaro and you want to know more about Lenaro Connect, as well as 96 Boards, you can visit the websites, and I'm going to put these. Actually, Sahaj, would you mind sharing those for me? Lenaro.org, 96boards.org, and connect.lenaro.org. So please feel free to go check those websites out. If you have any questions, let us know, and we will, hopefully, maybe some of you will end up going. That'd be nice. All right, next thing. We have a visitor in the call, and before we get into our main segment, our featured segment, we tried last week to talk about a new course, or a new, 96 boards in the classroom, so to say, and we were calling on Jung. Jung, are you here?
Yeah, I'm here.
Hey, his
Can you
audio
hear me?
working this time.
Yeah, finally. Hey, how are you?
Good, thank you. Thank you for joining us, man. We really appreciate it. I was really hoping you could take maybe a minute or two before we dive into, the episode itself.
Yeah, sure.
Give us a little update on, tell us about yourself too, real quick, and an update on what you're doing at UCSD.
Okay. Hi, good morning. So my name is Seung Jung, and I'm a student from UCSD majoring in electrical engineering. And me and other three teammates, we are working on this project as a part of our group design project course in UCSD. So this project is going to be a home automation for pet. Basically, what it does is that it allows the user to communicate with their pet in anywhere in the world with wireless communication. So we have three basic components of home node, user node, and modules. So we are going to conduct our home node on Dragon Ball 410C, and we're gonna connect our webcam and monitors. And for the user node, we are going to set up on our computer to receive and sending data. And for the modules, we are going to using a carbon and nitrogen board from the 96 board, and we're gonna using two expansion module which is like laser point to play with our cat, and then also room temperature monitors. So we are hoping to bring some good news to you guys soon. Some
Awesome.
exciting news. Thanks.
Yeah, Jung, thank you very much. And so I posted in the chat the link to their repository. So they are working on this. If anyone has anything they would like to share with them, or if you would like to give them some ideas on what they could add, but basically, just like Jung said, they're going to build a home kind of a home base station node with several portable and modules that you can add and move around your house. All of it's using 96 boards, and then they want to be able to tap into this, hopefully eventually with the phone app. But for now, it's going to be on your computer, right? So you'll be able to tap into it using your user node. That's what we're calling it. Jung, thank you so much for joining us and giving us an update.
Thank you for inviting me today.
Of course, thank you. And so they've also told me, the students in this team have told me that they will be providing us with weekly update blogs, right? So I did just receive one from them. They updated us on the last 4 weeks. So hopefully we can post that up onto the 96 Boards website soon, and we can stay up to speed with them. Again, if you want to visit their repository, they have it on the 96 Boards-projects org, and you can go find them under the Smart Portal repo right there in the link I shared. Take a deep breath. Okay, Mr. Karl Perry is here to join us to talk to us about, honestly, one of the most comprehensive and fun blogs that I have read in a while about a product that seemed to be forgotten. So let's first kind of go through the introductions, Karl. Maybe you could take a minute or two and tell us about yourself, what you do.
Sure. So I'm a Linux system administrator by trade. I do we call ourselves DevOps now, but whatever. I spend a lot of time doing that, and one of my side projects is I'm trying to start a hosting company that's based entirely on ARM. So one of the things that I'm playing with that is trying to find appropriate hardware. I've got a plethora of SBCs, some from 96 Boards, some from other places kind of around me, and I'm trying to build a system to be able to do hosting based on top of that. And so I was kind of excited when AMD announced the Seattle project, which was the A1100 Opteron. And there was, I got a chance to actually see it in the flesh at, I think it was the 2013 Open Compute Summit up in the San Francisco area. And they had they had the mini ITX development board, which I was very excited to see. And then they also had these things called group hug servers. I don't know if you've seen these, but it's a mini server that basically is on a 16x PCI Express card. And then you can load multiple of those into a 2U box. And so I was like, well, that's cool. When do we get our hands on these? And they're like, we're working on this thing called the Husky board, which I don't think ever came out. But 96 Boards and LeMaker made this thing called the Cello. And so pre-release came out for that, and I was like, sweet, sign me up for 2. And then it kind of went from there. So I have a lot of what we're going to talk about documented on my blog, and I know Robert is in the process of getting it posted onto the 96 Boards site, but I figured I'd post to, here's the link to mine if you want to follow along and look at the pretty pictures, because the pretty pictures can be exciting.
Cool, thank you.
So there were many months of delays in getting this board, and part of the problem for that was the PCI Express slot. The PCI Express slot on these boards does not function, unfortunately. Apparently there's something wrong with the receive side PHYs for the actual electrical connection, and it was never successfully debugged. They were working with AMD, and then apparently AMD ended the Seattle project, so that was the end of that.
So Karl,
yes.
Real quick, I want to kind of, because we're going to go through the blog here, but I want to just talk a little bit more about the board here. So I'm gonna show it up.
Yes.
So can everyone see that right there?
Yeah.
Okay. So before we dive into that, so this is the Cello board that he's talking about, and the Husky board was basically the exact same thing as this Cello board, only made by a different manufacturer, right? So like, I mean, essentially they tried making it twice. Eventually one of the manufacturers was able to get it kind of out, right? Now, talking about the Cello board, this is an enterprise version or an enterprise edition based on the 96 Boards standard. So it's the enterprise edition specification. And just to kind of give you an idea, right? So I'll pull up the high key right here, right? This is the size difference. All right. So this is the enterprise edition, and then this is the standard consumer edition. Okay. And basically the specification for each of these boards, I should say, consumer and enterprise edition boards, have multiple versions. Okay, so like you can get the consumer edition and then the consumer edition extended, which is a little bigger. There's the enterprise edition standard, and then there's the enterprise edition ATX form factor, right? So yeah, basically, I just wanted to kind of give a little crash course here, and just to let you know, Karl, it looks like Ard just joined as well. So,
I saw that.
Yeah. Yeah. Hello,
So
Ard.
huge shout out to Ard, because he was very kind in answering my emails over the last week to get a bunch of stuff, a bunch of questions answered, and help me get through the last couple steps of getting this up. So the short version, without having to read through the whole thing, is these boards showed up for me. Oops. Sorry, you there, Ard?
Yeah, I'm here.
Cool.
Do you want to maybe we should let him introduce himself real quick? Ard, do you want to just introduce yourself real quick?
Yeah, sure. Yeah, my name is Ard Biesheuvel. I've been with Linaro for more than 5 years now, working in the enterprise group, which is how I got involved with the Cello boards, while I don't usually get involved with working on these 96 boards, because most of them are in the consumer range. And yeah, it was so the Cello was an interesting project because it was such a nice SoC by AMD. And unfortunately, they kind of ceased development on it. So yeah,
That's kind of what Karl
here.
That's kind of what Karl was saying right before you joined. It's like he went to go see the SoC at a conference, or you went to go see it somewhere?
Yeah, it was at the Open Compute conference in 2013.
Yeah.
They had showed it off there.
Yeah. Cool.
Yeah, so it's a really nice design, and it's a bit dated now, but the PCI and everything works well. On the SoC it works fine, on the Cello not so much, unfortunately. Even though USB and network are also over PCI, so there's something strange in the SoC, and we didn't have enough documentation, and we couldn't really put our finger on it. And at the time, AMD were basically on their way out already, so it was very hard to get them to really care about what was going on.
Yeah.
Yeah.
Yeah. So Karl, sorry, what happened?
Oh yeah, I was just saying I still try to support the Cello from the software side. So last week or 2 weeks ago, I've been backporting these mitigations for Spectre and Meltdown into the secure firmware. So all of that is I'm trying to keep it up to date. Even though we have the number of users that I'm in touch with has doubled over the past week, because now there's you and my buddy Mark, who I know are active users of this board. But
awesome.
That's it basically.
Yeah, I'd love to get that firmware update at some point. When you've got it ready, just let me know.
Yes, I'll send you some binaries. Awesome.
I can even update this blog post. I'm hoping that Google's magic will discover this, and when people are searching for it for the, because there's like 200 boards out there, and I know several people have them. Everybody's kind of been in the same boat I have of how do we make these things work?
Yeah.
So I finally got these boards early 2017, and that was kind of where the fun began, and tried to get them up. Unfortunately, as soon as I got them, or as soon as they'd shipped, the day after they shipped, LeMaker emailed me to tell me that they forgot to put the firmware on my boards, which was exciting and made it slightly more difficult to get them up and running. They sent me instructions. Say again?
So did they tell you which firmware this was? Because I thought something about the I2C address that you had to program or something, but that's different firmware.
Yeah, so this appears to be Yeah, so I saw that same I2C address coming up when the SCP boots. So I imagine it's something to do with the system control processor, but I'm not sure.
Okay. Yeah.
I was unsuccessful in getting it programmed. Like, I just went and grabbed a Raspberry Pi that I had lying around, tried to wire up the I2C interface, and when I did an I2C detect, I got all ones back. So I was like, yep, I obviously screwed that up. So I wound up sending the boards back to LeMaker instead of getting that update done. But if somebody figures out how to do it, like, I'm sure all it was is like there might be a voltage difference. They didn't specify if that was the Pi is 3.3. I don't know if those are 3.3 or 1.8. It's also possible that I just needed pull-up resistors on the bus. I don't know. I didn't want to get too crazy, so I just kind of left it as is. And also, one of my boards was damaged. They had arrived stacked on top of each other in a box that was just the dimensions of the boards with some bubble wrap in it. And so, as what happens when you ship things internationally that way, they got banged up. The heatsink and CPU fan got ripped off of one of the boards. And that same board also had a corner chipped off of it. It didn't look like it actually affected any traces, but still not great. So I was lucky because at that point, LeMaker was still supporting them. And so they were happy to turn that around for me. Several more weeks passed because the speed of China Post when you send stuff e-packet. But I did eventually get them. And then in the meantime, discovered I had purchased the wrong memory. These boards take very specific ECC72 RAM, and it also requires an identical pair of it. There's two sockets on the board. There's one on the back and there's one on the front. And as you can see on the blog post, if you fail to plug in two modules, you get this lovely I don't know how to initialize your memory error. So fortunately, I had bought two 8 gig modules. My original goal was to have both machines running with 8 gig, but now they're both going to be running with 16. And plug the two modules in. At that point, it actually did start the boot process. The two secrets that Ard let me in on were there is a serial header on the board right here on the PCI Express, next to the PCI Express slot. This is a standard FTDI 6-pin connector. I don't have an FTDI cable lying around, but I do have a bunch of these ridiculously cheap USB TTL connectors, so I just wired one of those up instead. And you can see the output from the system control processor on that. So let me see if I can share my screen and I can actually show you some of that.
Yeah, so while you do that real quick, Carl, I want to address a question in the chat.
Sure.
Okay, so this is actually a CE question. Khushal asks, I hope I pronounced that right, I'm sorry. Khushal asks, the consumer edition has no heatsink or fan. It most probably runs off a very low CPU or ARM chip. So it depends on the chip. I think Sahaj kind of answered that, but like some of the boards do have a heatsink, right? So this is the High-Key 960. You can see that it has a little heatsink on there. The Dragon board, for instance, has a embedded heatsink into the PCB on the back. So some of the boards do have heat sinks, but for the most part, unless you're really, throttling it really high, you don't really need a heat sink in a lot of cases.
So the consumer edition devices have a cooling device. What that cooling device does is it slows down the CPU when it starts to overheat, which is intended so that when you try and decode a picture with your web browser, you browse to you think you get a burst of speed, but if you're running a long-term game, it will actually slow down the processor a little bit. And you don't usually want that in servers. You usually want them to consume as much power and process things as fast as possible. So the cooling device for enterprise devices tends to be active coolers like fans with, so as it gets hot, it should turn the fan on and off. It's probably turned on all the time on the Cello, I suspect, but on lots of machines, you'll see a fan speed up or slow down. But on embedded devices, they don't speed the fan up and down, they slow the processor down until it's thermally stable.
Nice. And so, and Carl, here's one more before we jump into your screen share. This one you can probably handle it. So he says, Cello, is there a special reason why the Cello board is so big compared to the consumer edition boards, right? But I mean, this can basically say, why is the Cello so big compared to other regular SBCs? I mean, like even you're talking Raspberry Pi, BeagleBone Black, 96 boards consumer. Like, why is the Cello so big?
There's two major reasons why it's so big, and one of them is it's got this full-size PCI Express 16x mechanical connector. So that, I mean, that's the majority of the height of the board right there. And then the other one is the expandable memory modules. They just take up space. Like you've got to run a bunch of stuff to it. A lot of the other boards, like that Heike you were holding up a moment ago, or even something like this this little Rock 64 board, like this has 4 gig of RAM on it, but it's soldered on the board. And because it's soldered on the board, one, it's not expandable, and they can reduce the number of or the length of the traces to get down to it. So the amount of space you need to connect that is absolutely tiny compared to these massive SODIMM sockets, which, you know, it's funny that I'm calling SODIMMs massive, but from a scale perspective, that's it. And then the other part of it is the actual SoC. Like you can kind of see from all of these passive components on the back, like this is not a small chip that's plugged in here. I don't know what the exact dimensions of it are, but it takes up probably a good 2/3 of the space underneath this heatsink fan combination. So they're just not small components, and that's the primary reason why these boards are so much bigger.
Boom. And then mic drop.
Something like that.
All right.
So
cool.
to your, go ahead.
No, go ahead. You're up. Yeah.
So to your point, yes, these do have active cooling, and you are correct. They do not throttle at all. As soon as you apply power to the board, it's spinning at 100%. And in being a tiny little fan, that means it's loud. So I've got it kind of over here out of the way so that we don't have to listen to it the whole time. But what's cool is, so the way I've got this screen set up is that there's two sides of it. The side on the left is going to be the output from the system control processor, and the side on the right is the output from the console port. So as soon as I apply power to the system, you'll see that the system control processor comes up and goes, oh, hey, look, there's stuff to do. And this is as far as I had gotten before. Ard was kind enough to tell me that there's a boot button that you have to push. So once you do that, you will actually see it do even more stuff. This takes several moments, but basically what it's doing at this point is it is seeing how much memory I have installed, calibrating delay loops, setting up all the physical interfaces on the board, of which there are many, clearing it, and then eventually starting the process of kicking over to UEFI, like that, and then UEFI starts. I'm a bad Linux system administrator. I don't know how to actually clear out everything from UEFI, so I already have Debian installed on this box, and it's actually going to come up and boot, but that's fine. So at this point, this is just a stock install of Debian 9. I just went and got the Debian 9 ARM64 ISO off of the Debian website. Plug that in, told UEFI that it was there, started the install process, and then it kind of went from there. The only two major problems I had were the network interface on apparently all of the Cello boards doesn't have a MAC address programmed in it. It works, but you have to specify a MAC address. Ard was telling me that the reason for this is because the manufacturer of the PHY that goes and provides the MAC address, the tool that they make for doing this, apparently they only ship as a x86 UEFI binary for programming the MAC address into the board. And at the time, Lenaro had not done the kind of astounding work of backporting, or not backporting, but implementing an x86 emulation layer in the ARM UEFI so that that tool could work. So these come up with no MAC address. There's two workarounds for it. The first one is, once you get Linux up, you can very easily tell Linux, hey, I've got a MAC address for you. And in fact, I will show you how I did that.
Carl, could you make this a little bigger?
Absolutely. Let me see what I can do here. Appearance. That might still fit on my screen. Better?
Oh, there you go. Yeah, way better.
Okay, cool. Advantage of having a 2K monitor. So what you can do here is in just your Etsy network interfaces, you can actually specify a hardware address. I made up this MAC address. This is the old AMD vendor code from back when they made network devices, and then the last 3 octets here I just made up. If you are like me and you have multiple cellos, you need to make sure they have unique MAC addresses. Otherwise, bad things happen. But by default, they just come up with all zeros. And after doing that, yeah, you can assign an IP address to it. DHCP works. You know, I can do the ubiquitous ping Google and it functions. Everything's grand. What doesn't work, however, is trying to net boot off of UEFI. Also, the Debian installer out of the box will not be able to talk to network repositories to go, or network mirrors, I should say, to go download all of the packages. So my gut instinct of downloading the DVD ISO and installing off of that was the right one, because when you do that, you can get the complete system installed without having to swap disks or anything else, and then later you can put in the information into the network interfaces file, and then add network mirrors afterwards, and life is grand.
Nice.
Also, a cute bit of trivia about the MAC addresses.
Yeah.
96 as the first byte is guaranteed not to collide with anything, because 96 has a bit set that says I'm a locally allocated MAC address.
Ah,
So
good to know.
I mean,
Okay.
You can actually have 96B0 if you want to start spelling 96 boards with it. But just useful bit of trivia.
Is that in the vendor part or in the other part?
Basically, there's a bit in the first byte of the MAC address which says
Okay.
I'm reserved for local allocation by the system administrator,
Right.
which means you won't collide with any hardware MAC addresses if that bit is set. And 96 happens to have that bit set, which is quite convenient.
Is that the same? I know there is a reserved block that like libvirt uses for virtualization. So when you're creating virtual machines, does that use it out of the same block or not? I can't remember.
That I can't say. You ought to be doing, but
Right. Yeah, part of the reason I didn't do that is like I run VMs all over the place with libvirt, and so I didn't want to be in the same area as that. So when I run into weird things like this, like what I tend to do is, you know, when I'm doing lots of VM testing, I'll go do something like you can change that prefix inside of libvirt to where it's going to generate the MAC address. And one of my favorite things to do is just like go dig through the MAC vendor list and find some ancient computer company that no longer exists that you have fond memories of, like Apollo Computer or Symbolics, because the likelihood of you having one of those on your network is pretty slim, and using that to avoid MAC address collisions. But same difference, I guess.
Yeah,
That's good to know.
So there's some more questions up here.
Yeah.
We can address them. They don't necessarily pertain to. I guess they could still pertain, but not so much to the cello or what you were talking about. But we should still get them out of the way.
Yeah.
So Khushal asks another question. This is back when we were still talking about heat dissipation and sinks and stuff. He says, does the 22 millimeter technology have better heat dissipation properties? It has lower power requirements, but still high frequencies would generate heat because the heat generated volume wouldn't improve a lot. So I'm gonna let you try to answer this one, Karl.
Yeah. So my understanding is the process does impact how much heat is being dissipated from the chip. Like for example, my friends down the street at AMD, their current socks that they're building, the new APUs, they're at a 14 or a 10 nanometer process, which means they can fit 4 x86 cores and a GPU in something like a 15 watt TDP. which is impressive. But process isn't all of it. When you do a process shrink, you obviously get a reduction in heat, mainly because the amount of voltage that you have to pass through the system is less. But it also depends on what you clock it at. So a great example would be Odroid has this board called the XU4. It's based on a Samsung Enos part. That comes in two variants. One is passively cooled, one is actively cooled. And then they also took that same sock and put it on the HC1 and the HC2, which you can actually plug a, they come in this awesome heatsink / chassis that lets you plug in a 2.5-inch SATA hard drive for the HC1. The HC2 will let you plug in a full 3.5-inch SATA drive. That thing takes a lot of power. It's like 6 amps of 5 volts to boot that board. And so it dissipates a fair amount of heat, which is why that entire case acts as a heat sink on that, that sock. That sock is probably 22 nanometer or less. So it just depends on what you're doing, how the system is clocked. And as was being mentioned before, like what your use case is. Like if you're doing something where you are bursting on the core, passive is going to work fine, which is why the Raspberry Pis don't come with heat sinks. But if you're going to be using it for more than just, you know, typey and the occasional sketch program, you're going to want to throw a heatsink on there in order to get the system to be a little more performant.
Nice, cool. Well, there you go. I think that was it when it comes to heat sink or heat questions. Okay. So now I guess I have some questions here about your use cases, or Daniel. I'm sorry, I should say, because Daniel is our resident tech liaison.
Okay.
Daniel, did you have anything to add to that?
Not especially, no. I mean, I don't fully understand the question. It talks about heat density, but the reality is, as you shrink the process, as was said, it uses less power. So although it's hitting a smaller area and it's harder to dissipate, it's also, you know, generating less power in the first place.
Yeah. All right, cool. So I have some questions about your use cases with the Cello, because you were saying that you were using them for hosting.
That was my game plan, yeah. So originally I purchased these two boards because they have 2 SATA sockets. And that's huge. Like trying to find ARM boards that have SATA ports that are native has been really difficult for me. Most of the other, there's a couple other boards that I've seen, like the PCduino 3, based on the Allwinner A10 sock. The A10 and the A20 both have a native SATA port that is quasi-supported. Like it's not even in the data sheet that it exists, but everybody found it and started using it, and it seems to be okay. The Jetson TK1 also has a SATA slot on it, and it's a little weird. But this has 2, and so my game plan was to drop 8 gig of RAM into these 2 machines, a couple of hard drives so that I could do RAID 1, and then have these be the database servers for the back end for the hosting platform. Just run Postgres on either of them, and then have my web front-end app and various other back-end processes talking to that Postgres database. Unfortunately, because of a lot of the weirdness with this board, like having to push buttons to make it boot, it's not going to be super... It's not the best idea to go throw this in a data center where I don't necessarily have someone there in case something goes wrong. I toyed with the idea of, like, you know, getting some solenoids, hooking them up to an Arduino and be able to, like, have it push the buttons when I need to, but I was like, that's taking this a little too far. So I'm just going to leave these. Go ahead.
I'm surprised they don't have a way to toggle that input, like through a signal. Like, I mean, why would you have to push the button?
It requires them to be able to do that. So in principle, if it's followed the specs, the low speed connector has copies of the power button and the reset button.
Yeah, so that's what I'm saying. So like this.
If you drop if you drop the what's it called, the UART mezzanine on top of it, you in principle can toggle the power and reset via a USB connection. It's still not great in server environments because USB isn't great in data centers, but
right.
You should find that the power pin is present in a accessible form via the low-speed connector.
Yeah. Yeah. So what I'm doing right now is the platform that I've built for my hosting currently is based on all of those Odroid HC1s. I've got 8 of those in a 2U chassis stacked up on edge. There's a 16-port switch behind it, power supplies to drive everything over on the side. And then I am, here, let me turn this off so you can actually see my picture. I am building, I've got a nice little Trinket Pro from Adafruit here that I'm going to be tying into a giant 8-port relay board like this. I've also got a smaller one for an NTP server project that I've already got deployed in the data center. And basically, I'll be able to have a little Raspberry Pi Zero talk to this over I2C and be able to say, hey, turn this relay on, turn this relay off. And then voila, I've got a way to power on and power off those systems because they just boot as soon as they have power, which is nice. And then I've got a bunch of those El Cheapo USB serial adapters plugged into a little hub. These are going to hang off of the Raspberry Pi as well, and then now I have console on all of those machines. So it's a little janky. it's very Southern engineered, but the price of data center grade ARM stuff is no cheaper than buying something from Intel or AMD, which is kind of silly to me. And since I'm bootstrapping all of this from my own funds, like I wanted to try and get it up with as little capital expenditure as possible. So that's part of the reason why I'm going down this path. You may have seen in the blog post at one point, LeMaker offered to give everyone who had the Cello the ability to swap it out for a Hikey 960. And I passed on that opportunity simply because you had mentioned USB is not great in a data center. Wi-Fi is even worse. And all of the Hikey boards, they only have Wi-Fi for network connectivity. Sure, I could have gotten an Ethernet board that could plug into a mini PCI Express socket, but I was going to have to use that PCI Express socket for SATA as well, and so I was like, yeah, no, that's not going to work. Trying to jury rig something where that's coming out and goes into some sort of PCI Express bus splitter so that I can have the network card and a SATA bridge is no. So
yeah, I think the next step for that, when it comes to, I mean, granted, it still comes out to being a pain in the butt, but yeah. There's this board right here. So we did talk about this at one point. It's still not available for sale, easily available for sale. But this is an Ethernet PoE, so power over Ethernet board, and this could plug essentially, like I'll show you right here. So I have the Hikey 960 here in my hands, and it plugs right in on top, right into the low speed and high. Oh, I have the metal thing there still, the safety piece. So this plugs right into the low speed header and the high speed header, and then you have like that.
Yeah, that's cool.
Yeah, and that's the Hikey 960 with the little Ethernet there, and then you still keep your PCIe port there available as well.
Nice. What's how is that connected? Like, is there actually another PCI Express slot that goes, or PCI Express port that goes through on the high-speed connector?
No. Oh, wait. Actually, is there?
No, it's USB pins on the high-speed connector. So there's USB D plus D minus.
Yeah. And then this board also has a TPM on it, so there's security features on the Ethernet board.
Neat.
Yeah. Yes, it's cool. Anyways, hopefully one day this board becomes for sale, because we talked about it like months ago. We brought someone in from Arrow to talk about this Ethernet board, and then it never went live.
Yeah, it turns out hardware's hard.
Yeah.
I kind of like, I've backed a fair number of hardware Kickstarters. Like I had a stack of 24 Pine 64 boards because that was going to be the platform I was going to use at one point, but errors were made there in how they manufactured it. And like, I said, I've done a lot of Kickstarters based on hardware, and I find it really entertaining when everybody gets all bent out of shape when physical objects take longer to produce and have problems. And I'm like, guys, this is not easy.
Yeah.
Even when you're just tinkering with Arduinos, it's not easy. So yeah, no, I get it, and I know how that can go.
Yeah. So Guillermo says right now in the chat to go back to the boot button discussion. He says boot button, you need to hack it with the 555 ancient timer chip wired for a single pulse that will pull the boot button low or high for a few milliseconds as needed.
Yeah, I could totally do that. I could also, like, take something like I have the Arduino and just plug in an opto isolator so that it will do the right thing and trigger it on and off. Like, it's not the end of the world. It's just for what I plan to do instead, because like I said, the other part of the problem is there's no cases for the Enterprise Edition boards at all that I've been able to find.
There are not that I know. Oh wait, actually, someone was working on one. I should share this while you're talking about it.
That would be cool.
Yes.
I have a design for a laser cutter online.
Oh, perfect! Because that's what I was going to do. Is I was going to go design one, and I was actually going to make one modification to it, which is I was going to take off that tiny little obnoxious fan and put in a giant 120 millimeter fan on top, so it's nice and quiet.
So this is the link right there to the EE case. I don't know how far along it is, but yeah, it's there. The other thing is that it looks like Daniel, while you were talking about your USB relay, he just wanted to make sure that we knew he did it first.
That's not quite what I said.
He shared his GitHub repository there with the USB relay instructions.
You literally built what I built. That's hysterical.
Yeah.
That's what I used to
it's exactly.
It's not quite the same. I didn't use I2C, but
interesting. Yeah, the primary reason I was looking at using I2C is that so my game plan, and I'll go look at your code. So I'm going to probably make some assumptions that you may not have made, but like I didn't want to have the relays on while the computers were on. So the idea was to connect it so that when they're normally closed, they're on. So I wanted the microcontroller to boot as quickly as possible. And this may be different for the microcontroller you have, but for the Trinket Pros from Adafruit, if they're plugged in via USB, there's like a 6-second timeout while they wait for you to see if you're going to attempt to bootstrap code onto them. If you have something connected over USB, if you just have 5 volts plugged into it, it boots instantly. And then talking to it through I2C is not a big deal. Also, I wanted to throw some like environmental sensors in the case and stuff like that. So I need to talk over I2C anyway, so it wasn't really the end of the world.
Yeah, so those relay boards are great though, because you can build so many things with those. Because they're cheap. If anybody's wondering and watching, they're about $7 for the relay board. And
something like that. Yeah, they're super cheap. You can get them if you're willing to pay a little bit more. You can get them on Amazon with Prime shipping. I also found this one on Amazon, which is like fully built out, but I have absolutely no idea how it works.
I saw that one and I decided not to buy it for exactly that reason.
Right. I was hoping there was going to be some like markings on it of like who made it, or no, nothing. But it is an Atmel, and like the ISP header is right there, so I could plug in a JTAG and try and download the code off of it, fully expecting it to be copy protected so that you can't read it, and then I'll figure something out at some point. But yeah, highly entertaining.
Nice. So we're coming kind of to the end of the hour. We kind of try to start closing out at about 50 past 10 till. Did you have anything else? We don't have to stop, Karl. But did you have anything else you wanted to share? Did you have?
Not particularly. Like, if anybody's got questions, like, feel free to reach out. I also, the comment section on my blog, I monitor. So feel free to leave comments there if somebody's like watching this later and has questions. I'm
share
happy
the blog.
to.
So Karl,
Let's share the blog one more time. Oh,
yeah.
Hey, what's up? This just in case you're interested, this is the Poplar, and
Yes.
I have
I just saw your blog post on 96 Boards earlier today about how you had gotten the PCI Express working. So that's awesome.
Yeah.
Yeah, the primary thing that kind of turned me off on the Poplar is that it's only 2 gig of RAM, like, which is cool, but like if you want to do something like run a database, not so much. Robert, it looks like that case that you posted, I did see that one, the 3D printed OpenSCAD one. But the only thing that I was concerned with that is like I know my 3D printer can't make a case big enough to put the board in. So I was actually going to try and do the same thing that Daniel did. I'm going to look at his design. It looks like the one he has is for the consumer edition. I don't know.
I've got them for the consumer and the enterprise. I mean, it's only really the shape and the holes in the right position.
Yeah, that's basically what I was going to try and do.
You'll have to add a cutout for the PCIe, which I need to do at some point. But
Yeah,
I intended the showcases. They're designed to go to CES and make them look shiny.
Nice.
So having a cutout is unnecessary.
I will look at that, and if I can, there's the EE stuff. So
Yeah.
what I was planning on doing was basically the same thing of, simple acrylic case. A friend of mine's got a laser cutter. In fact, I'm meeting him for lunch here shortly. And see if we can do that. I was going to put a cutout on it so that if you have something like the Poplar, you can actually use the PCI Express slot. And then make the minor modifications so that you can put the 120 millimeter fan on top of it. Oh, that's gorgeous.
Yeah.
That's my Poplar. I haven't got a cello, but that's my Poplar. I can't leave the camera on long or the machine will crash. But that's the Poplar board that I have.
Nice, very cool.
And this is another one of Daniel's masterpieces. This was for the Orange Pi. So you have like 22 divided by 7, and then the 96 boards etching on the back. I lost a couple of the screws and the bolt, or the nuts in the back.
Yep.
So I had to take my board out of it. Kind of sucks.
That happens all the time.
I can bring you some more. But that Orange Pi one was the hardest possible case because the Orange Pi has just got all these extra bits of wire hanging off it that you've got the cutouts for and things. So that was a really hard case, that one.
The other thing that was like, and like I'm not placing blame, but the one thing that I did notice is that when I was trying to design like how am I going to put these in a data center, when I was doing that, I was like, man, there's like connectors on all sides of the board. Like I can't just like put it in a regular case, which is super annoying. You actually want to be able to reach stuff on the front and the back at the same time, which is cool when it's sitting on your desk and not so cool when you have it, down the street, locked behind doors that you can only get into 8 to 5.
There's a mechanical problem with the PCIe connector as well. The bottom mount hole can't be used if you have a full-size graphics card in there because there should be a lock connector on the back if it was a different design. So we realised this when we got the Poplar, which does have a lock connector on the back, and unfortunately, the lock connector is in the way of the mounting hole.
Yeah. Well, like I said, I figured I was probably not gonna like my kind of design. My vision was basically the same thing you have, like just a solid board on the bottom, some standards in the middle. I would probably make the standoffs plastic just because the not having to worry about ESD and things like that. And then basically I was just going to have the top board end like right about here, so that if you are using something like the Popular and you want to plug in a GTX 1080 because you're crazy, are kind of crazy, you could do that. And then, like I said, just have the mount on top for the fan, so I can pop this fan off, plug in the 120 millimeter, and then it'll be nice and quiet. Since I'm not going to use them for the hosting stuff, instead, my game plan is I'm involved with the Works on ARM community out of Packet, and so I'm hoping to build a open source CI pipeline that other people can take advantage of. And these two will be compile servers because they got 16 gig of RAM. And then I've got a myriad of other machines that I was going to set up as tests so that you can basically put in a software definition for an open source project. It would build it, and then you can go pick which machines you want it to run on, have it all go through Jenkins or hopefully some other less terrible CI pipeline so that people can contribute. And then packages come out the other side in an S3 or a Dream Objects bucket, so that the world can have more ARM software, because that's a good thing. So
Absolutely. So are you going to ELC next month?
I am not. I was actually going to ask you earlier, are they going to live stream any of that or have recordings available afterwards?
They usually do.
Okay.
So usually most of what they do there, they have a live stream, or not a live stream. They have recordings after they release them all.
Yeah. I probably will not be able to make it next month. I like Hong Kong is one of my favorite cities, so I would love to go back.
Oh no,
But,
that ELC is in Oregon.
Oh,
Yeah,
I
yeah.
missed that one. Sorry, I thought we were talking about Lenaro Connect.
No, yeah, Lenaro Connect is in Hong Kong, but the ELC is in Oregon. That's March 12th through 14th.
Oh.
Yeah, that one's usually kind of fun.
I am unfamiliar with that one, but I will have to look it up. What's
Yeah,
ELC stand for?
Embedded Linux Conference.
Oh, right.
Yeah. Yeah, so it's a good one. I definitely like that one. But
Nice.
I noticed Ard, you got kind of quiet. You didn't have anything call it. He fell asleep at the wheel.
No, I'm here. I'm just listening.
Art, I
okay,
hope
cool.
you do not mind that I basically cut and paste your instructions verbatim onto my blog on how to make the EFI application for setting up the MAC address and the PCI config space. I didn't actually test it, but I was like, if anybody wants to try it, here's all the stuff you need.
Yeah, no, that's fine. I should have tested myself probably, but well, I did test it when I wrote the code.
Excellent.
And I just dug it up and recompiled it for you, so I didn't
Cool.
test it
I appreciate it.
again. But yeah, I'm pretty sure it works.
Yeah,
And
that's awesome. Like I didn't get a chance to go I just got these boards up a couple days ago. I haven't had a chance to go load that into the EFI environment and then see if I can get the net boot operation to function. I've also never been able to successfully net boot a UEFI box, so there's a whole other world of pain waiting for me there as well.
I should probably just add if I'm doing a firmware update, I'd probably add HTTP boot in there,
Oh, that would be super helpful.
because you can just point it anywhere and it will just boot it for you,
Yeah.
which is rather helpful.
Yeah, I have a love-hate relationship with UEFI.
Yeah, well, everybody, even the people working on it, have that. So
Yeah.
don't worry about it.
Great. So we're basically towards the end of the hour. I usually do the closing out now, but any last words, Karl?
I'm good. And Robert, Ard, thank you so much for your help in getting these up and running. It's great to not have them be paperweight sitting in my drawer.
My pleasure, and I'm quite excited actually that people are using it, because it's such a nice. Well, the board has its shortcomings, obviously, but this SoC is so nice, and it's such a shame that the project wasn't really that successful.
Yeah.
So yeah, if you're any questions, anything at all, just ping me and I'll try to help.
Awesome. I appreciate it. Thank you so much.
Yes, and on another note, just to let you know, if you do have any questions for any of the people who work at Lenaro in the 96 boards team, or just in Lenaro in general, you can go to IRC, and most of the the more involved developers, you can find all of them on in 3 different channels. So let me just post these here, but IRC, you can go to either #96boards. You can go to #OpenHours. We love hanging out with everyone in there throughout the week, and #Lenaro. So those 3 channels, you can basically find. I mean, I don't know, Ard, you must be in IRC, right?
Yes, all the time.
So, and Daniel Thompson's in IRC. I hang out in IRC. Sahaj. I think every single developer is in there. So there you go. Once again, Karl, thank you very much. Ard, thank you for joining us. Daniel, as always, thank you for participating and helping out with all of the things you help with. Everything, basically. And yeah, one last thing, right? So, of course, 96 Boards has a forum. So please bring your questions to the forum too, because that is a more recorded channel, right? So like then people can go search them, and the questions that got answered one time can get answered again for someone else. Let me just share now before I do the closing. I have the 96 Boards community forum. So for those of you who are not familiar with the community forum, I share it once a week, and you have an opportunity, community forum, to earn community points. Now we are going to be kind of redoing our system and implementing a little bit more intricate system around the community points. But for now, this is what we're using. So the code for this week is going to be Open Cello. There you go. And if you want to earn your community points for this week of Open Hours, go to the forum, fill it out, and they will get tallied. And I plan on sending out a gift or a package for the community winner this upcoming month. So hopefully in hopefully in March, I will announce the next community winner during episode 96. And I intend it to be a pretty rad gift this time. So I know Ragnar won it last time. He got a bunch of like 96 Boards goodies and some swag. It'll probably be something along those lines, but with some a little addition to that. So we'll see. All right, closing announcements. I kind of did them all, but one last thing. Make sure you check out the Linaro Connect page, connect.linaro.org. Keep in touch or keep on top of our 96 Boards blogs. You can go to 96boards.org and click blogs. And those we release, I think, 1 or 2 of them a week. So there's lots of interesting stuff. Just like Karl said, he ran across the Poplar with the PCIe blog. And then on top of that, we are doing a huge revamp to our documentation repositories and our website repositories. So next week, we will be addressing this. We will be talking about all of the new additions. And then I hope that I'm also hoping to have a surprise demo for a new project that we have been working on as well. So stay tuned for that. And thank you everyone for joining us as we slowly transition out. The 3 recordings will begin to drop off, but thank you very much. And Karl, once again, thank you for your participation. We look forward to having you on the show again.
No problem. My pleasure.
Awesome. All right, cool. Well, this has been Open Hours episode 90. Signing out. If you want to stick around for after hours, the recording's going to turn off, but we just hang out. I pour another coffee and we hang out for another few minutes. But, thank you.
Recording has stopped.
Sahaj, or did you already turn it off?
I turned it off and then turned it back on as soon as you said.
Oh, it's okay. Don't even worry about it. Okay. Bye, Facebook. Thank you. Facebook's going off now.
The broad